Today I am here going to present topic on to control cracking of gravity dam. My name is Ashish Bharat and I'm from civil second year. So the content of my presentation is introduction and different method to control cracking in concrete dam. First one is by using low heat cement, by pre-cooling of concrete, by post-cooling of concrete, by reducing percentage of cement, by providing contraction joint, time interval between concrete lifts, and by limiting the height of lifts. So next one. First of all, the introduction about my topic. Dams are made up of concrete. You also know the structures are made up of generally concrete and RCC. And dams are made up of concrete and need to withstand huge amount of pressure. It means the pressure exerted by water on the body of dam, and that pressure is handled by dam. And they also need to handle temperature variation like seasonal variation, summer, winter, and monsoon also. So due to that also the cracks are occurs. The main two reasons, the main two factors like pressure and temperature. Pressure and temperature, these are the main cause of occurring cracks in concrete. Cracks may develop internally or externally also. The external crack pour more dangerous in concrete dam than internal crack, because when the crack is occur on an external surface, their water will penetrate and they damage more to the structure. Likewise, and the cracks are developed internally in the body of dam or externally surface of the dam. Surface crack are more dangerous than interior cracks. So for this purpose we have to control the crack in gravity dam or concrete dam. So the method, in reference method, the first method is by using low heat cement. What is low heat cement? The low heat cement, it means the bogus compounds like tricalcium aluminate, tricalcium silicate, and tetracalcium and aluminum ferrite, and dicalcium silicate also. There are four bogus compounds. In mass concreting structure like dam, and the heat involved during the hydration process. We also know when cement mix with water, they start a hydration process, and the heat is dissipate very slowly, will cause an increase of temperature inside the concrete, and mass thermal crack will occur. Due to this hydration process, there will be thermal cracks will be occur. To prevent this, we will use low heat cement for our dams, used to use in place of ordinary Portland cement. We know it that OPC, ordinary Portland cement, tricalcium silicate and dicalcium silicate, they are mainly reason to occur the cracks and in our low heat cement, there consist of uh, high amount of C2S. It means calcium dicalcium silicate, and less amount of tricalcium silicate and tricalcium aluminate. As a result, the rate of heat production as well as the rate of hydration is slow in this case. So that's why we are controlling using low heat cement. Also we are control some cracks, hence the temperature inside the concrete is controlled and can be prevented. So next one, by pre-cooling of concrete. Pre-cooling of concrete, it means cracks can be prevented by pre-cooling of concrete ingredients such as fine aggregate, coarse aggregate, and this is done by the blowing air through the aggregate, or by washing them with chilled water. When we spread or we just wash that material with water, material will be cool, and there will be no any hot material there, Concrete can also be pre-cooled by the cool water for its making. This will balance the heat generation during hydration process and prevent the thermal cracking. And next one, by post cooling of concrete. Post cooling of concrete is done by passing cold water through pipe embedded in concrete. For post cooling, 250-meter long and thin pipe of 25 mm external diameter are placed in concrete. After each lift is poured, all pipes are connected together by expansion coupling. Uh, these pipes are spread at 0.5 meter to 2 meter horizontally. After completing the concreting of one block of the dam, cold water is immediately passed through this pipe at velocity 0.6 meter per second and continue until the mass concreting temperature fall in local temperature. To take the temperature, resist a thermometer and is installed in concrete mass. Next one, by reducing percentage of cement. We also know when we increase the percentage of cement, there will be occur hydration process. The higher the cement content, higher will be the heat generation and hydration. The rate of heat is discollected is very show in interior portion of the dam compared to the exterior part, because exterior part is expose the heat easily, but internal part is not easily. So due to that also thermal crack are occurs. To reduce this, cement content and use to construction for interior portion in the dam, general if x amount of cement is used for exterior portion of the dam, the 20% reduction with 0.88 xn amount of preferred to the interior portion of the dam. Then next one is providing contraction joint. We also know due to the temperature variation we have to provide joints like expansion joint and contraction joint. In a gravity dam we have to provide contraction joint. Contraction joint are provided in concrete dam to prevent the crack from due to shrinkage. When shrinkage when shrinkage of concrete, there occur cracks, so we have to provide contraction joint. If contraction joint are provided parallel to the axis of dam, they are called as longitudinal joint, and it's they provided normal to the axis of dam, called as transverse joint. Transverse joints also continuous and speed of distance 15 meter height of the dam, which are less. So by providing contraction joint we also control some cracks. And next one is a time interval between concrete lift. We also know when we are working on site, the lift between concretes, like our structure is more big like gravity dam, so we have to take some interval for concrete lifts. In mass concreting structure like dam, the concrete is a poured lift, which there should be good time interval between successive lift. To prevent cracking due to shrinkage, time period of 3 to 4 days is recommended between successive lift. It means almost 1 to 1.5 meter lift. After that we have to wait for 3 to 4 days. Then next one, by lifting of height by limiting the height of lift. By limiting the height of lift, the height of concrete lift should not be greater than 1.5 meter, prevent cracking in mass concrete. Thank you.